Quite a couple of words about me. So I'm one of the co-authors of Browser Hackers Handbook, which is going to be released, I think, around like February, March next year. Mario is the technical reviewer, so thanks for him to collaborate with this. I'm the lead core developer of BeEF, and I do like application security for a living and for fun. And I'm a fan of all those things in the bottom, not particularly in that order. So what we're going to speak about today. This is something that some research that I presented originally in RacksCon last year, but I went a bit farther, and also thanks to Bart Lerpens, which should be here somewhere. Yeah, he also ported this kind of shellcode to Linux. So the idea here is that we are going to speak about ways to attack from the hooked browser that you control with BeEF, so any browser that you can control with JavaScript, attack systems in the internal network which are not speaking even HTTP, and if those systems are vulnerable to classic like overflows, you can even compromise them from the hooked browser and communicate with that system from the hooked browser. So you can send shellcode, and then you can speak with the shellcode in a particular way we will see later. There are obviously limitations, it's not so easy, it was a pain in the ass to develop all these things, but thanks to multiple people we managed to do it. Then we will have a couple of demos at the end, and yeah. So the idea is that, I guess there are a lot of guys in this audience that, you find bugs in browsers, sometimes like use after free or this kind of low-level stuff, but you know better than me that it's difficult to find them, and yeah, if you sell the 0 day, you can get a lot of money, but if you want to buy, actually, you actually need to pay a lot of money, Greg said. So, and also, except from Firefox, all the other browsers more or less implement a kind of sandbox. So if you find a bug in, I don't know, the JavaScript parser, then it's not automatic that you can execute commands in the operating system. So you need also to bypass the sandbox. So, it's becoming increasingly more difficult year after year, plus there are the bug bounties and stuff. So, at the end, how many useful browser exploits we have? Especially, like, a lot of those exploits were based on Java, or using the Java plugin for rope chains. Java right now, well, from like a year and a half, 2 years, is not so useful anymore, especially thanks to click-to-play features and the new features in Java 7 that requires explicit user intervention. So, I mean, what can you do if you have like a browser that is fully patched, is not leaking plugins? Firefox right now is the only browser that still leaks like proper versions, build versions, just querying navigator.plugin. All the other browsers are just leaking the names, so it's not so useful anymore if you want to use like a properly passive approach without injecting applets or flash stuff to check the version. So in this kind of situation, you can still use our old friend cross-site scripting. So although there are a lot of restrictions, so like same origin policy, now content security policy starting to be used, a lot of headers restriction like X-frame option and stuff, still you find XSS in 90% of your pen tests, and 90% of the applications are vulnerable to this kind of attacks. So, and believe me, there is much more than just doing a pop-up with alert 1. The point is that, while you are researching all browser vulnerabilities, and at the same time internal servers in the internal network where the hooked browser is are sitting there, bored and lonely, waiting to be compromised. So I guess you know BeEF? Raise your hands. Ah, that's great. So I don't need to introduce it. I get bored to do that, to be honest. So, as you know, we can skip this. And the idea we had with BeEF, with Wade, and with the other developers, Bart, is basically that we would like to have like a platform like Metasploit, where every time you have an exploit that is something you can launch through the browser, so something HTTP, no HTTP, and you can do it from JavaScript with like a cross-origin XML HTTP request, port it to BeEF in a way that everyone can use it if it's not too private. So that's the idea behind it. And obviously, antiviruses cannot detect BeEF because it's like working on a different layer. And if you want, there are some attacks that can be detected, obviously. But if you don't deliver, like, if you don't touch the file system, if you don't deliver, like, malicious Java stuff or other exploits, there is no way that they're gonna, it's gonna be detected. And everything is, done with JavaScript. And that's a good idea. So the whole thing about inter-protocol communication exploitation started with Wade a couple of, a bunch of years ago. Like before 2006, he was researching basically ways to communicate with protocols that are not HTTP and having the commands interpreted in some way. So the idea here is that if you send a post request, let's say to a ASCII-based protocol like IMAP, SMTP, POP, IRC, and many others, even JetDirect, the printer protocol. Basically, whatever you are sending is going to be parsed. So if you send a HTTP post request, the headers will be ignored as bad commands. But then if you, in the post body, you have like login Michele, pass Michele, and the server is IMAP, it's going to parse those commands properly, and if the credentials are valid, you are going to be logged in. That's the way, basically, this is the way it works. So we have like, in this case, we are creating like dynamically an HTML form with content type text plain, so we don't have to like use www form URL encoded. So the request is properly clear, and this is basically the raw request that arrives to the IMAP server, and these are the logs of the IMAP server. Is an IMAP server in Windows. As you can see here, all the headers are ignored because the protocol parser doesn't implement this kind of stuff, obviously. But then on the login, you see that the credentials are properly interpreted. So this is basically the basics of inter-protocol communication. It is the same with SMTP and other implementation. Depending on the implementation, like for example, postfix is great because it's not great for us as an attacker, but it's great in security speaking, because after 5 or 6 commands that are not recognized, it's dropping the connection. But depending on the protocol implementation, you can find still a lot of stuff that works in this way. Now, obviously, there are limitations, and if you are looking forward to what's the next step of this, so basically, if the where is it? The login. Let's say that you have like a Stack Overflow pre-authentication on the login command. Obviously, instead of sending just a string, you are going to send a shellcode, and it's going to run. We will see that later. So remember that we are doing everything from the hooked browser, meaning that you need to fight with the same origin policy, cross-domain, cross-origin restrictions, port banning, a lot of stuff. And then also, as we will see later, when you send this big request, depending on the service, the headers are going to be kept in memory, so in the same buffer where basically your shellcode should land. So you need to consider also the size of the headers before sending the exploit. But the results are properly nice, to be honest. So the idea, the point is that this is probably something not so new. Every browser except Opera, if you do an XML HTTP request cross-origin, the request is arriving anyway, even in the latest Internet Explorer. The request is arriving anyway. You cannot read the response. You can just monitor the timing of the response, and that's another thing that allowed me to do other stuff with time-based blind SQL injection cross-origin, but that's another story. So the point is that as soon as you know that, for example, this web application is vulnerable to remote command execution, you can basically just send the request blindly. And then if the remote command execution vector is, for example, creating a reverse netcat back to your servers, you don't care to see if the request was successful or not. You just wait to see if your payload is executing later. And this is obviously enough to pawn services. It's going to be better, obviously, reading the response, but unless you have a soft bypass, you can do that. Now, the biggest limitation is probably port banning, which was implemented in a non-very consistent way in most of the browsers, like back in 95, 96. Firefox was the first browser implementing it, and Basically, port banning prevents you to send HTTP requests to ports that are not allowed. Like, you cannot send an HTTP request to port 25. You cannot send an HTTP request to port 143. So basically, as far as I know, the only way to not even bypass, like, get away of this is injecting a malicious Firefox extension in the browser, which disables the port banning on the port that you want. So there is like a pref.js file in every Firefox extension where you can define what to override in the about config options. And you can override, obviously, all these kind of ports. As far as I know, I mean, I don't know any other way to get around port banning. Probably there will be in the future, so these kind of techniques are obviously much more powerful if you can disable completely port banning. But at the same time, port banning is basically saying you cannot connect to this, and that port. So it's about 60 ports out of the whole range. And there are a lot of examples that are not port banned. Like Firefox and Internet Explorer are the only two browsers that they don't ban IRC ports. So you can play with NAT pinning, you can play with targeting IRC servers or speaking with IRC servers on port 6667. IMAP3 is not really used, but still there are people that are binding this port, and that's blocked only by Internet Explorer. Other ports, you know that there are a lot of services that are listening on high ports like Java Stuff, Java RMI, HP OpenView. JetDirect is basically every HP printer or Canon. They have this port. You connect to Netcat and you send the stuff you want. So you can basically do it also from the browser and other ports. Now, another limitation, as I said, is the fact that when you send this request, the headers are usually kept inside memory. So, as when you are playing with an exploit, you are calculating how much space you have for your shellcode, you send your patterns, you do the calculations. Basically, the HTTP headers, in that case, need to be considered as like the knobs that you are sending, or like the garbage you are sending before you want the return address to go back where you want. So in order to account that, we will see later a way to reliably calculate the headers, which is basically sending a cross-origin request back to a server we control and checking exactly byte by byte the size. Then obviously, if you inject the Firefox extension to disable port banning, you can also like override the user agent and save even like other 100 bytes. You can say now the user agent will be Firefox 15 instead of all that blob that is common in every user agent. And the last thing is that, the content type, you can either use text plain or multi-part form data, because are the only two where you have like proper like blank part of the post body without any kind of formatting, so you can put the data there, and it's like when the protocol parser of the server that you are targeting arrives on that part of the post body, is going to parse it like normal netcat or telnet connections with carriage return line feeds and data. So the point is that after exploitation, instead of like delivering, I don't know, a reverse TCP connection back to Metasploit, if you are using like one of the Metasploit payloads, the good thing is that you can communicate with the compromised service through the hooked browser. So it's a fully bidirectional channel from the hooked browser. Why? Because basically the web shell, so this is basically what happens. You trick the victim, for example, to install a Firefox extension to disable port banning, or you don't need to do that if you are targeting something that is not port banned, which is very probable. JavaScript port scanning on, for example, port 143, and these are like known techniques, so I'm not covering them. After you identify that the port is open, obviously, again, if you don't have a SOAP bypass, you can't fingerprint exactly the response from that service. So you just send it blindly. But the point is that if you send it blindly and the target is not vulnerable, nothing is going to happen. Otherwise, you're going to get the code executed. Then you basically send the stager with the exploit. The stage, we will see anyway demos and stuff later, so don't worry. And then when everything will run on the compromised machine, instead of having like, you see the red arrow, instead of having like a reverse connection back which might be, I don't know, filtered by egress filtering solutions, for example. You just communicate completely to the hooked browser, because basically the shellcode is returning access control allow origin wildcard, and you can communicate easily with like normal Ajax request and reading the response. So Time Miller created this kind of shellcode, and it's basically like a staging shellcode where you have a small stager, and then the stager binds a port, and you send to it a stage later on. And after you deploy the stager, which is basically the part you send normally in your exploits, a port 4444 is binded and is basically waiting for the stage to be injected in memory, and the stage is delivered through a cross-origin post request with a command parameter, like CMD parameter. So after you send after the stager is running, you send the stage with this post cross-origin, and when also the stage is allocated in memory and is completely running, is basically, as I said before, emulating a small web server, which returns access control origin, so allows communication from whatever origin, reading the response. And what the shellcode is doing is basically like redirecting input-output with some pipes of CMD exe, or in case of the BART shellcode, with like execv for Linux, and spawn a command, gets the output, and send it back in the HTTP response. So obviously, the shellcode is binary data. So the way to deal with like the moment when you send the exploit, and also the moment when you send the stage. So every time you need to deal with binary data, thanks for Mozilla, we love you. They implemented a great method called send as binary, which basically allows us to send like, you know, hexadecimal encoded stuff. So for example, there will be also Wireshark screenshots anyway. So this is, for example, the cross-origin post request with the exploit and the stager inside, and then the second one is on the port that is binded by the stager 4444, and is the delivery of the stage. So if you don't have send as binary, like Internet Explorer, Chrome, Safari, so WebKit-based browser, like Chrome and Safari, they still support like array buffer, so that is like a polyfill that you can use to achieve the same. The only issue is that, as far as I know, unless you start Chrome with a different command line option, there is no way to basically disable port binding, like with an extension or something. But let's see what's happening in next years, I don't know. Now, the other thing is that we cannot know in advance the exact size of HTTP headers, as I said before. So the way is that the hooked browser, before targeting the service, sends the request back to BeEF on a different socket. So basically, you are still emulating the cross-origin scenario, and you can exactly know that, you know, those headers that you are parsing will be the same one as those that are going to be sent to the target, with the difference of the host header, of course, which is recalculated. And in this way, basically, you can have a super reliable exploit that is exit by byte, and you don't need to be basically scared about the fact that, you know, your shellcode is not properly landing and stuff like that. So for example, now there will be demos, so hold on. Like in a typical like structured exception handler exploit with an egg hunter in this IMAP service, which is the exploit that we are going to cover now. If you have a classic, like, you know, like command junk shellcode and then the pointers and then egg hunter, in this case, with this technique, the idea is that usually, especially if the bug is pre-auth, so before entering credentials, usually you need to account for HTTP headers. Then obviously you put less junk or less knobs if you need them, and then the rest is exactly the same. So in fact, if you attach a debugger, I don't know if it's very clear, but if you attach a debugger and you look on the left, you can see that basically on the blue line, yeah, you basically see, like, you know, the headers in the memory of the process. So that's why you're going to see that you need to account for HTTP headers. There are exceptions. It depends on basically the protocol implementation. But basically, as far as you check with the debugger how it works, you port the exploit to be launched from the browser with this technique, and you port it once and you use it every time. And this is the raw view of what's happening basically when you send on the left, when you send the exploit, it was like a SCH overflow on the list command, pre-authentication. So as you can see, like there are some knobs, then there is like the string that is being searched by the egg hunter, BeEF. Then there is like the stager, the egg hunter. And then when that's executed, port 444 will be binded on the target host. And the second request, which is not covered here, is like sending the stage, which is basically the same kind of request as this one, with the exception that here you have like other shellcode, which is the stage, the second part. And then when that is delivered, you can interact with that particular port just with normal cross-origin post. So in the command value, you put like a command, the command is spawned, you get the response back in the HTTP response. And there is also like a small like JavaScript shell in BeEF that facilitates you with, compromising the system. So as soon as that's delivered, you point like which one is your target, then you can type it, but I need to improve that. Yeah, so let's have a look at the demo. So in this way, in this case, we are simulating like a social engineering attack, where you have like defined in etc hosts like bing.com instead of Bing to point to one of your servers inside the network, and with BeEF, with the BeEF social engineering extension that I coded a year and a half ago, you can basically say it's like the social engineering toolkit. Like you point to a URL, you say clone this, and it's going to be cloned and mounted where you want, and you can control that entirely with a RESTful API. So in this case, this has been mounted on our BeEF server, and the page also contains the BeEF hook. So as soon as you clone a website, the BeEF hook is injected, and you can control the browser. So the communication is also quite fast because I'm using the WebSocket channel, which is there from almost 2 years now. So now we are just confirming that the browser is there and you can control it. And the next step is, as I said, is delivering a Firefox extension, which you can do with what kind of social engineering tricks you can imagine. In this case, for example, we are simulating like a fake flash update. Now also, remember that Firefox extensions can still be delivered by any origin, right? So in this case, we are simulating like a fake flash update in OS X. When the victim clicks somewhere, like in install, there are a couple of clicks, obviously, but it's up to you to basically have this kind of attack more, less clicky and more convincing, like backdooring extension, for example. Now, in this case, you see another look at browser because we changed the user agent and we changed other properties in the browser itself. So this looks like a new one, but it's the same. Now that with this extension, the port banding is fully disabled for the ports we need, the next step is just identifying which systems in the internal network are actually alive, so which one we can eventually port scan to see which services are running, right? This is just the details of the extension. Okay. Yeah, ping sweep. So now this is like a video from like 4 or 5 months ago, and this is when you could still run easily Java in Firefox without even using an applet. You can do the same anyway with pure JavaScript right now, with ping sweeping, still with timing the response, and it's something that I'm covering in the book, and port scanning as well. So in this case, we identify that there is this 135 host alive. We want to port scan only port 143, and after a couple of seconds, we can basically identify that port 143 is effectively open, and this is just doing like a cross-origin HTTP request, which comes back quite quickly if the service is available. Otherwise, it times out. Now, this virtual machine is Service Pack 3. I didn't want to play with that, like SLR and stuff. So Eudora Mail, which there was already an exploit, again, it was a bit modified to work with this technique. So as you can see, it's just listening. There is no port 444 open, so it's not a joke. Like, it's not, I'm not cheating. So now that we know that this host has port 143 open, we don't know exactly the version and the type of IMAP server. So we are just going to try to send the only exploit we have. Obviously, in a best case scenario, you have multiple exploits, like when you use like browser autopwn with Metasploit or something like that. Now, console log just for debugging purposes. Now, all those requests that looks like aborted are aborted only in Firebug. Like they look aborted, but the request is really going through. And as you can see, even if they are read, some of them are even replying. And the stager is being sent, and all the calculations are being done to send reliably the shellcode. And the exploit should be successful. So in the Windows machine, if you do netstat, you see port 444 for listening, which is our shellcode. And at this stage, you just connect to it, and what's going to happen is that post requests are going to be sent, and commands are going to be executed, and the response is going to be returned back in the HTML response. So you don't have any kind of reverse sockets outside the company. So if you have a hooked browser inside this internal network of the company you want to target, everything is going through it. So if you use, for example, something we are developing is not there yet, public, like DNS tunneling, bidirectional, completely from the hooked browser, it's going to be, more difficult and more difficult to detect that something is going on, instead of using reverse TCP connections. So now we are interacting already with the system. So we are just going into the C directory and doing a dir. I need to improve the interactivity of the like prompt command, but that's fine. Now, not just to confirm that we are actually executing code, that we have really access to the system. We are just creating like a file with nothing inside because the command was wrong. But yeah, copy whatever inside BeEF text. So BeEF text is created inside the C directory. And yeah, when you do dir, yeah, it's there, and then it's confirmed also, yeah, here. So basically, yeah, you interact fully with the browser. You compromise the service from the browser, and you interact with the compromised server entirely from the browser. Now, the last example, and then okay, so as I said, the previous example was Windows and was the shellcode developed by Tai. So Bart did a great job on basically porting the shellcode to Linux. And the stage and the stage are even smaller, so even better, because if you deal with exploits that have like limited space and stuff, it's much better. So obviously you can use it in two ways, either with normal exploits or as the example that I will show you later now, in remote command execution vectors. So every time you have a remote command execution in a web app, for example, at runs Linux, the remote command execution could be like wget this binary, change mod, and then executes it, and the binary will be basically the compiled shellcode. And the example I'm going to show you now is exactly that. So BeEF bind Linux on an exploit with Trixbox, which is like a VoIP solution. There was a pre-auth remote command execution, and then also pre-auth XSS was quite pwnable. Now the exploit was already in exploit.db. What I did is I changed the vector. I found another XSS that allowed me to read some stuff. Because the exploit was quite tricky to achieve remote command execution, because there was like local file inclusion, and basically you can achieve also remote command execution because you was able to store inside the $_session variable your code And then as a second request, you could request that the session, as your like remote command execution vector was living inside the session, you could do a second request to read like temp ses with the PHP session ID value, and you could trigger the exploit with 2 requests, basically. So as you can see here, like lang choice was vulnerable, so you just do like PHP exec, and base64 just to don't play with post encoding. And the vector was, as you see, like wget this binary of the particular shellcode from like a website we control, chmod, and put it in temp, and then run it in the background, redirecting input output. So basically, when this payload will run, you can interact with it as we see before. And again, everything from the browser, and especially because these applications are likely to be inside the internal network. So you can identify them, like requesting known images. These are all techniques that are still useful. You identify them, like scanning a range of internal IP address, like Gareth Eyes demonstrated with like JSLAN scanner back in the day. With routers, so you can apply that with every web applications if you can identify known resources. After you identify that, you proceed basically in this case with an XSS, where we are injecting the just the BeEF hook instead of playing with alerts. And so basically now we control the whole domain, and that's something needed because when the second request that triggers the remote command execution, you need to know the PHP session ID. So you can even do it cross-origin, having a, like an XSS vector that sends back to you the cookie value. But if you do it same origin in this case through the XSS vector, it's going to be even better and more reliable. So we just copy the whole exploit that sends the remote command execution vector and send 2 requests. We are using raw JavaScript, which is a module in BeEF that allows you to send basically whatever you want, and everything will be executed. So this is basically the remote command execution vector that is base64, and it's going to live in the session with the first post. The second post, this one here, is needed to trigger what we have in the session, because we are asking like the web application to read what is contained in the PHP session ID in the session, the $session variable. As you can see, the remote command execution was successful. We have BeEF bind listening on port 4444. Now in this case, was just the stager. You could also like run the stager and the stage all together. So there is a step less, which is this one, the next one. But this is just a demo. I want to show all the steps. So the second step is sending the stage, again with the cross-origin XML HTTP request, which send as binary. And this is basically what is being sent. As you can see, there are some parts of the shellcode that are clearly like plain text. So like the headers over there, content length, content type, and the course header as well. The request is sent, and what we can do right now, again, entirely from the hooked browser, simply with like 5 lines of JavaScript, which is basically like send a text plain request and get the response when the state is 4. We are basically going to interact with the compromise system as we would do from a different machine on a different reverse socket. So in this case, I'm going to ask, can you please tell me the ID of the process? And this, you see, asterisk is like an asterisk-based software, this Trixbox thing. And and the final proof is basically doing a netstat and checking if BeEF bind itself is running, and of course this will return. Yeah. So that's basically our communication channel. And last thing, I'm basically finished. This is basically what's really happening. So thanks to the course header, we can even get a response. And that's the trick. So yeah, I mean, I don't have anything else. So I would like to thank Wade, the other BeEF developers, Ty and Bart for the awesome shellcode, Mario, the other speakers, and you all. And well, if you was interested, if this talk was interesting to you, the book will be even more interesting. So just buy it. Questions with beers later. Thank you very much.